Welcome back and thank you for joining. In this lesson, we'll explore horizontal translations in sine and cosine functions. If you remember from unit number 3, we have observed horizontal translations in parent functions, and we've said that any parent function can be horizontally translated following this equation. So y equals f of x minus d, where d indicates a horizontal translation. Now, when it comes to sine and cosine functions, instead of letter D, we'll be using the letter P. Letter P stands for phase shift. Because these are periodic functions, the horizontal translations will happen or will occur in phases. And that is the reason why we use the letter P instead of D. Now we're going to take a look at y equals sine of x minus 60. In this case, we're going to say that the phase shift P is equal to 60. The way that we look into at this is we look at the number that we are subtracting from x. So if we are subtracting a positive number from x, it means that the value of P will be positive. And if we're subtracting a negative number from x, which seems to or appears on the equation as a positive sign in here because of the two minuses that turn into a plus, then we'll say that the horizontal translation has happened in the negative direction, and the value of p is negative 30 degrees. So when we draw the graph of this function, we'll look into the 5 important points as we always have, and let me just highlight them for us here. So these are the 5 important points. So for sine of x minus 60, then we'll have all these points translated 60 degrees to the right. So 60 degrees to the right, 60 degrees to the right, 60 to the right. Remember that one unit here is 30 degrees, right? That's why we go by twos. And the equation or the graph of this function would look like this. So in the same way, we transform sine of x into sine of x plus 30 by translating the graph 30 degrees to the left this time. So again, we refer to the important points of the basic function, sine of x, and all the points will go 30 degrees to the left, which in this case is 1 unit horizontally, right, to the left. And we connect all the points together, and as you can see here, we have created the graph of sine of x plus 30. So in the same way, we look into the graphs of cosine functions. So this time we have y equals cosine of x plus 30. So similarly, we say that we have to look at what number have we subtracted from x. So since we see a plus sign here, it seems that we have subtracted a negative 30. So that means that this function has undergone horizontal translation of 30 degrees to the left, and the value of p is equal to negative 30. So negative stands for the left. Now, if you draw to draw the graph of this function, again, we look at the 5 important points for the cosine function is the 2 maximums, the minimum, and the 2 x-intercepts. And we'll move all these points 30 degrees to the left. So as you can see here, 30 degrees is represented by 1 unit. So we'll say that every point has to move 30 or 1 unit to the left in here. 30 degrees or 1 unit. And here goes the cosine curve that's been translated 30 degrees to the left. In the same way, we can draw the graph of y equals cosine of x minus 90. So in this case, we see that we have subtracted positive 90 degrees from x, which means that the value of p is 90, positive 90, which indicates a horizontal translation of 90 degrees to the right. So every point on the cosine curve will be translated 90 degrees to the right. So here we go. We're having this point in here, 90 degrees will be 3 squares in here, 3 units, because every unit is 30 degrees. So we're going to move the first point here. Now 1, 2, 3, so that's 90 degrees to the right. Again, 90 degrees to the right for this, 90 degrees to the right for the next point. So from 270 to 360. And the last one will also be 90 degrees to the right, which seems that it's a little bit off the grid in here, but I'm just going to estimate it in this case. Here we go. Connect the dots. And voila, this would be the graph of cosine of x minus 90. So the green one is a horizontal translation to the left 30, and the blue one is a horizontal translation to the right of 90. As you can see, the translations do not change the shape of the graph. It's simply a whole translation of the entire function by the indicated number of units. Now, when you look at the max, min, and equation of axis of symmetry, you probably can see that the maximum and the minimum stayed the same as for the basic function. So we're going to continue writing for the first one, sine of x minus 60, which is this blue graph in here. You see that max, min, axis of symmetry stayed the same as the basic function. So the maximum is 1, the minimum is -1, and the axis of symmetry is at y equals 0. So the same thing happened for the sine of x plus 30. So the max, the min, the axis of symmetry did not change. So the max, the min, axis of symmetry remained the same. Okay, now what that means is that the horizontal translations do not cause any changes in min, max, and equation of the axis of symmetry. And when you look at the amplitude, again, the amplitude is the same. The amplitude is affected by the vertical transformations. So that will be vertical translations or vertical stretches, and there is none of them applied in here. So the amplitude will be the same for all these functions, so equal to absolute value of a, which is equal to 1, same as the basic functions. The equation of the axis of symmetry remained the same at y equals 0. Now the minimum and the maximum again remain the same, minimum -1 and maximum +1. Now, what are though the changes that, or what are the things we look at when we transform a function horizontally by translating it? So it's not, this is not a very formal definition, but I would say that the first cycle of the graph is the one that is closest to the y-axis. So for example, when you have cosine of x plus 30, this would be considered the first cycle. But we know that we can continue drawing this function in both directions, in the positives and in the negatives. But when we look at the equation of the function, we always try to stay as close as possible to the y-axis. So for the basic function, you see that it will start at 0, it will end 360 degree later, so from 0 to 360. And that is same as the period length. So from the starting point, we add the period length to hit the end point of the graph. So when it comes to horizontally translating a function, the starting point and the ending point of the graph will change. And very often in many exercises, you will see that you will be given the starting and the ending point of the graph, and you will be asked to determine what the period length is, because between the beginning and the end of one cycle, there is a period length kind of gap. And this is what we will try to practice in the following questions. So in the next example, we have to draw the graphs and identify minimum, maximum, and axis of symmetry, and the start and the end point of each graph. So negative sine x minus 45. As you can see here, we have the value of a equal to -1. So that will give an amplitude of 1. And we have a horizontal translation of 45 degrees to the right, because the value of p is positive 45. We have subtracted a positive 45 from the function. And there is no vertical translation, so that means that the coefficient C is equal to 0. And A, B, C, and then we see that the coefficient K here is equal to 1, so we don't have any stretches in the horizontal direction, so that means that the period length would be equal to 360 degrees. Now, to find the minimum or the maximum, if you remember, we said that we have to start at the axis of symmetry, which in our case is 0, and for the minimum, we subtract the amplitude. And amplitude in our case would be equal to 1, so 0 minus 1 is negative 1. For maximum, we start from the axis of symmetry, which in our case is 0, then we add the amplitude, so 0 plus 1, that would be equal to 1. The axis of symmetry would be at y equals 0. When it comes to the starting and the ending point of the cycle, then we're going to say that this cycle will start at 45 degrees, because of the horizontal translation of 45 to the right. We can consider that as the closest point to the y-axis where the cycle starts, and it will end from P. So this is going to be, the starting point will be the horizontal translation, P, and the ending point will be the horizontal translation P plus the period length. And with a period length of 360 degrees, we're going to say that we are at 45 degrees plus 360. And that will make, or it will take the graph all the way to 405 degrees. So the end point of the graph will be at 405. Now, in the same way, we'll reason about y equals 3 cos x plus 60. I would start off by identifying the coefficients A equals 3 in our case. The value of k is equal to 1. You see that we are subtracting negative 60 in this case. So subtracting a negative 60 means that the value of p must be equal to negative 60. And there is no vertical translation, so c equals 0. So there is a vertical expansion 3 times taller. There is no horizontal expansion or horizontal compression. There is a horizontal translation of 60 to the left and no vertical translations. Now, for minimum, maximum, and axis of symmetry, we always refer to the vertical coefficients, which are A and C. The axis of symmetry, again, is y equals c. In our case, y equals 0. So the maximum and the minimum are determined by the formula. So for minimum, we have from axis of symmetry c, we subtract the amplitude. So that would be equal to 0 subtract amplitude of 3, negative 3. And for the maximum, we have from axis of symmetry, we add the amplitude, so 0 plus 3, which would be equal to 3. So the cycle in this case will have to start at negative 60 degrees, and with a period length of 360 degrees. So same as the basic function, as the basic sine, cosine x. We will have this end at negative 60 plus 360. So this cycle, or the first cycle of the graph, will end at 300 degrees. Let me make this a little bit bolder. 300 degrees. So if we were to draw the graphs of these two functions, this is what we would do. So we would start off by observing first the min and the max. So negative 1 and 1. So that will help us determine the location of the x-axis. So the location of the x-axis should allow equal number of units above and below it, because the y values are positive and negative 1, min and max. Now the horizontal translation is to the right, which means that we can give a lot of room to ourselves on the right side of the graph. And we can start with drawing the axis of symmetry, which we know is going to be at y equals 0. And labeling the vertical axis, which should accommodate the min and the max, positive and negative 1. So with this, we are done with the vertical axis. We need to scale the horizontal axis. So when I scale the horizontal axis, I always look into the horizontal translation because I want to make it very clear where the horizontal translation is located. So if it is at 45 degrees, for example, I would say that I'm going to want my first unit here to be 45 degrees, and I would go by 45 degrees. So this is where you hit a 90. So, and next, another 45 degrees will take us to 135. Add another 45 degrees, so another unit. So that would take us to 180 degrees. I will extend this axis right here. So it seems that we need a little bit more room. And we have another unit. So we're gonna need another 180 starting from here at least. We need to hit 405, by the way. And I am going to bring this a little bit more to my left. Oopsie. Okay. All right, it seems that we have crossed some boundaries in here. All right, so I'm gonna try my best to fit everything in this part of the graph. So here we go. We have 1, 2, 3, 4, and I'm gonna need just a tiny little bit more room in here. 5, and maybe I can move just this axis a little further. And I'm gonna move this one here a little further. It seems we can do this. Okay, so I should have planned this a little bit better, apparently. And here we have 1 and negative 1. Okay, so now we should have plenty of room. So 180, another 45, 225, and then another 45, it's gonna be 270. Another 45 is gonna be 315. And then we have in here 360 and 405. So in our case then, we're going to start the graph of sine right at 45, and we'll finish up at 405. So 45 to 405. Now, as you can see here, we have 360 degrees distance between the beginning and the end of the graph, and halfway this will be another x-intercept. So you see 1, 2, 3, 4, 5, 6, 7, 8 units. So that means that 4 units, 2, 3, 4. So that would be where the next x-intercept will be. It seems that I have moved, actually, I can move this one a little bit more to the left to make it fair. And now, this is something very important that we need to pay attention to. You see that there is a reflection of the y values. That's because a is negative, which means that this graph, instead of going this way, it will go the other way around, reflected about the x-axis. So what that means is that minimum first and maximum second. And there goes the graph of this function. Now, in the same way, we're going to draw the graph of 3 cosine x plus 60. So again, we're going to start off with first identifying the min and the max. They're at opposite values of y. So they're opposite values, which means the x-axis can sit in the middle. Now we have a horizontal translation to the left, which means that we're going to need a little bit of room on the left side of the graph. And we're going to start off by scaling the axis. And the y-axis is the easier one in this case. Remember that we need to fit the coordinates of y equal to 3 and negative 3. So we're going to let these two values in here be 3 and negative 3. And then we're going to start with the scale of the x-axis. So for the x-axis, we need to make sure that we have 60 degrees to the left. So I'm going to go 60 right here. Negative 60 degrees, that's a 0. So that means that's 60. And then I have 120. And then I have 180. And then another 60, 240. Another 60 is 300. And I think that's all I need because the cycle is ending at 300 degrees. Now remember, this is a cosine cycle. We're going to need to accommodate the 5 important points. There are no reflections, so it's going to be the shape of the classic or the basic cosine function. So we're going to start with the max and end with the max. So here goes the max and ending with the max at 300 degrees. Now halfway, so remember that you have 1, 2, 3, 4, 5, 6 little increments in here. So that will help you determine where halfway of the graph is. And it seems that it's at 120. And now we have to determine where the intercepts are. So remember, the intercepts will be halfway, the start and the middle of the graph. That's the first x-intercept. And the next x-intercept is halfway between 120 and 300. So you have 3 little units in here. So it seems that it's going to be between 180 and 240. And now you can draw the graph by connecting these important points. And voila, this is the graph of 3 cosine of x plus 60. So in the next example, we have to draw the graph of a 1 cycle of a sine function. It starts at 120, ends at 480. It has a point of minimum, which is equal to 0. And the maximum is going to be equal to 4. Period length is 360. We have to find the equation of the graph as well. So I'm going to start by drawing the graph of this function. So let's read the question one more time and clarify what information we're given. So we're given 120 and 480 as the start and the end point of the graph. So what that means is that the graph starting at 120 and ending at 480 suggests that the period length of this graph will be the difference between 480 and 120. 480 minus 120 is 360 degrees. So that tells us that there are no horizontal stretches, which means that the coefficient k must be equal to 1. So when you draw the graph of this function, you're going to need to draw the y-axis somewhere in the middle, like leaving a little bit of room for the positive values of x. Now, you see that the value of y is minimum of 0, maximum of 4, which means that you're going to need to place the horizontal axis down below because most of the graph is going to be above the x-axis. So the next thing that we want to do is scale. So we need to have the y value of 0 and the y value of 4, which is the maximum. 1, 2, 3, 4. Or another actually more efficient way is to maximize or optimize the space in here of the graph so the graph is clear and not a tiny little graph on a big space. So what you want to do is let this be the entire 4 units. So the highest you can go halfway for number 2. Halfway, this one is going to be 1, and then here's number 3. So the y-axis is scaled. Now for the x-axis, we know we have to start at 120, go 480. So I'm going to say that for 120, I'm going to go by increments of 60 degrees, and that would be 120. And I'm going to keep going with increments of 60, so that's a 180. And we'll continue with 60 more, 240. So remember, we're ending at 480. So you see that you have 240 in here, and it is 1, 2, 3, 4 units, right? So you're going to go 1, 2, 3, 4 more units, and I will hit 480. okay, degrees. So let's take a look at what we have created now. So we will have to draw the graph that has a minimum of 0, maximum of 4, period length of 360. So it seems that the graph is going to start exactly at 120 and it's going to end at 480. So the lowest value of y is going to be 0, the highest is going to be 4. So it seems that the graph of this function will be somewhere in this little tiny box that I'm going to draw here. Okay, so this would be the period length of the function. This is going to be the height, the total height of the graph of the function. Now the way I like to think is we can draw the x-axis right here in the middle, the axis of symmetry right here in the middle. As you can see, if you draw the axis of symmetry, it will fall at y equals 2. So that's AOS. Now remember that AOS is normally y equals c. So with this, we have discovered that the value of c is equal to 1. If you want to do this algebraically, then you can say that c is the average of max and min, which means that we add them together and divide by 2. So in our case, we have 4 plus 0 divided by 2, that equals 2. So we got the value of c as well. Now, since the function starts at 120 degrees, and it is a sine function, so since it starts at 120, that will give us the phase shift. So the starting point of the graph will give us the phase shift P, 120 degrees. Now, the endpoint of the graph is used to also determine the coefficient k. Now, as you can see also, the maximum is 4, the minimum is 1, which will make the maximum 2 units far from the axis of symmetry. So we're going to write that down as well. So max is 2 higher than axis of symmetry, above axis of symmetry. So that will make the coefficient a equal to positive 2. And now we can draw the sine function. Now remember that we're going to need the 5 points. Then the sine function will start and end with the former x-intercepts. And then in the middle we'll have the other x-intercept. And halfway you will have the max and the min. And there goes the graph of this beautiful sine function. Now it is also very important that whenever you draw these points, we have to also make sure that they are aligned with the x values as well. So between 180 and 240, there is 60 degrees, so that must be at 210. So x is 210 degrees and y is 4. So continue drawing the rest of the graph, and we'll have to hit 0 somewhere in here. Okay, so I would just put in this to align my points. And you see that if you keep on scaling this is going to be 300 degrees. So this is going to be a 420. And this is going to be 360. So what that means is that right here at the minimum, we are at 390 degrees. So the minimum will be at 390 and 0. And this would be the graph of this function. Now, if you want to write the equation of it, remember the equation of any transform sine function will be in the form a equals sine kx minus p plus c. And all we have to do here is substitute a, k, p, and c. And that will give us y equals to sine k is equal to 1, x minus 120 degrees, and the vertical translation of 2. And that would be the equation of this little function right here. In the same way, I would like you to please try example number 5. Thank you for learning with me, and bye for now.